In the previous video, we explored the Indian and Babylonian positional number systems. For more than 1,000 years, the Babylonians lived with a serious problem, a problem hidden inside their own number system. Today, let's understand that problem. We'll use our own base 10 number system to do it. Look at these two numbers, 104, 14. What's the difference? At first, that sounds like a strange question, doesn't it? Let's look a little closer. In both numbers, the digit 4 has the same value, 4 ones. What about the digit 1? In 14, it's in the tens place, so its value is 10. In 104, it's in the hundreds place, so its value is 100. But there's something else. In 104, the tens place is empty. That's why we write 0. In short, we use 0 to show that a place has no value. That's the difference between these two numbers. Now imagine, there was no 0. How would you write 104? You couldn't. The only thing you could write is 14. That was exactly the problem the Babylonians faced. They had no symbol to show that a place was empty. Today, that sounds almost unbelievable. We've grown up with 0. So it's difficult for us to imagine a number system without it. But for the Babylonians, this wasn't a small inconvenience. It was a real problem. Let me show you why this was such a serious problem. About 3,000 years ago, the Babylonians wrote a mathematics problem on a clay tablet. It says, the square of 227 is 6, 9. That's written in their base 60 number system. Let's convert it into base 10. It becomes the square of 147 is 369. The moment you see that, you know it's wrong. So what's the correct answer? 21,609. Now let's convert that answer back into base 60. Compare the answer on the clay tablet with the correct one. Can you spot the difference? The Babylonians had no symbol to show that a place was empty. So instead of writing 609, they wrote 69. The Babylonians knew the calculation perfectly. The mathematics wasn't the problem. Writing it down was. So how did they manage? They understood the number from the context. Here's a simple example. Imagine your friend sends you a message, but there's a problem. The spacebar on their phone isn't working, so the message looks like this. Even then, you can still figure out what they meant. The Babylonians read numbers the same way. They use the context to understand the intended value. The Babylonians lived with this problem for more than 1,000 years. Later, they started leaving a space between two numbers. That helped. But it wasn't enough. So they invented a symbol. Was that symbol their version of 0? No. It was simply a symbol for nothing. So why don't we call it 0? Because there's an important difference. The Babylonians never treated this symbol as a number. They used it only to show that a place was empty. That's a little difficult for us to imagine today. From the time we were children, we've always thought of 0 as a number. So it's hard for us to separate these two ideas, a symbol for nothing and the number 0. About 2,000 years ago, Indian mathematicians began using a dot to represent 0. Later, that dot became a circle. In Sanskrit, it was called Shunya. For the first few centuries, it was still used only as a symbol for nothing. 0 had not yet become a number. Then, something remarkable happened. Brahmagupta began treating 0 as a number. That was a major turning point in the history of numbers. But Brahmagupta didn't stop there. He also explained how 0 should be used in arithmetic. He defined 0 as the result of subtracting a number from itself. He also explained what happens when you add 0 to a number, subtract 0 from a number, or multiply a number by 0. Brahmagupta also wrote about commercial mathematics. In those writings, he uses 3 important terms: Dhana, Rina, and Shunya. He explained his arithmetic rules using the language of commerce. Take your time and read each one carefully. If you'd like, pause the video. As far as we know, Brahmagupta was the first mathematician to systematically explain zero as a mathematical quantity that could be used in arithmetic. Before that, no one treated zero as a mathematical quantity. It was simply a symbol for nothing. Now let's move on to one more idea. Today, we think of negative numbers as numbers that lie to the left of zero on the number line. But Brahmagupta saw them differently. To him, negative quantities meant debt, and positive quantities meant fortune. In the next video, we'll explore how negative numbers slowly found their place in mathematics. Let's quickly summarize what we've seen in this video. At first, zero was simply a symbol for nothing. Over time, it became a number. It sounds like a simple idea, but it took over 2000 years to reach that point. Before we finish, here's one last question. Brahmagupta wrote a few more rules involving zero. Take a look at them. Which of these rules are correct and which are wrong? Let's see what you think.